Let's start by talking to this light sensor here. It is plugged into this 2-pin header, which on one pin provide power, VCC, and on the other pin is connected to ground via 1K resistor, and also connected to analog port 6. This is the type of wiring we need for this light sensor. It's called a pull-down resistor. First, I'm going to declare a const for the analog port we're going to use. Then I'm going to declare the ADC manager instance. This instance will allow me to talk to the analog to digital converter chip here on the board. It is an MCP3008. This chip is an SPI device which is on the board wired this way. The select pin is on GPIO 3. MOSI is on GPIO 1, MISO on GPIO 2, and the clock on GPIO 0. And then we call the method begin. At this point, I am ready to read voltage values from this header here, or from this other header pins that have special configuration. What I could do now is create an analog light sensor object from the Nusbio library. But such a light sensor needs to be calibrated. The function calibrate light sensor will just do that. In this block of code, we are defining that if the value read from the ADC, which is connected to the light sensor, is between 0 and 100, then the light level is defined as dark. Between 101 and 244, it is office night. Between 245 and 499, it is office day. And between 500 and 1000, it is defined out outdoor sunlight. It is up to you to calibrate the sensor for the type of light you need to detect. I'm creating an instance of the analog light sensor class and pass it to the function calibrate light sensor with the type of sensor. And then the function will return the instance calibrated. I'm going to query the light sensor every half a second. Therefore, I'm declaring a timeout object with a 500 millisecond period. This block of code will be executed every half a second. First, we're going to use the ADC manager and call the method read and request the value for the analog port number 6. And then we're going to pass the value read to the method setAnalogValue. We can now display information. I'm going to display first the property calibrated value. This will be dark or office night or office day or outdoor sunlight. The analog value is the value we read directly from the ADC. We will also display the voltage value. The voltage value and the analog value represent the same thing, but with different units. Let's run the app. For now, we display office day because we are in my office and there is a lot of lights on. I'm going to turn some of the lights off around me. And now we detect the light level decrease and it's office night. And if I put my finger on the light sensor, it is now dark. Let's turn the lights on. What I'm going to try to do now is to move one of the lights directly on top of the sensor. And now, as you see, it detects that is outdoor sunlight. This concludes the first demo of the Nusbio Analog extension combined with a light sensor.